Now, as you go back in time, we as geologists talk about icehouse and greenhouse climates. So now I'm going to move into millions of years timescales. So if we go back to 40 million years ago, this, for those of you that are stratigraphers in the class, this is the boundary between the Oligocene and the Eocene. This is when Antarctica was first glaciated. And so those of us that sort of think about big glacial, interglacial, greenhouse versus icehouse climate transitions, this is a big one because that's when Antarctica first got glaciated, coming forward in time. So if you go back to 41 million years ago, Antarctica is not glaciated. If you get to 39 million years ago, Antarctica is glaciated. So that's a big transition. And sea level dropped, global temperatures dropped, CO2 dropped, very dramatic. So if you go back into the Eocene, we get temperatures and a world that you really wouldn't recognize because sea level is much, much higher than it is today. There's no continental ice at all. Even Antarctica doesn't have any ice on it. So you can imagine sea level which is almost 100 meters higher than it is today. So almost all the great cities on the planet would be flooded. And that's a future that we can look forward to if we continue to pump CO2 into the atmosphere. Because that's also the last time the planet had the kind of CO2 levels that we are looking to achieve by the end of this century. So that's kind of a very sobering thought, and why scientists today are saying, listen, you don't really want to flood New York, Paris, London, Shanghai, Tokyo, Yokohama. It's not a good thing, right? But that's where we're headed from a paleoceanography, paleoclimate perspective. So that's what the Eocene was like. High CO2, very warm, no continental ice.